Hello and welcome to my video on 16 colour tiles for the Game Boy Advance. In this tutorial I'm going to go through how the tiles are made up, the colours, and then I'll talk about the tile maps for displaying our 16 colour tiles. I'll quickly show you the tool I use to convert my graphics to the Game Boy Advance format. In an upcoming video I will show an in-depth usage of this tool and I will supply the source code for you to use yourself. I'll also jump through and show my demo program for 16 color tiles and how you may use the code for your own programs going forward. Okay, so let's kind of jump in here. So the Game Boy Advance 16 color tiles, it uses unsigned 32-bit numbers for each row of the pixels in an 8x8 pixel tile. So it's actually very similar to the Sega Mega Drive's format to some degree, except that so this is an unsigned 32 number here in hexadecimal, and it actually is kind of nice to work with this. So again, it is actually 8 bytes here, or rather 4 bytes per row if you like. So the easiest way to think of it is if you think of this as like our virtual palette, so you would have 0 to 15 giving us our 16 colors for our palette for our tile, and then each of the pixels corresponds to one nibble in the unsigned 32-bit number. So a nibble is basically 4 bits in a byte. So you can think of, if you think of like a byte, which is 8 bits split in 2, then half of that is a nibble. And the bit flags, when switched on, can form a number between 0 and 15. As this is in hexadecimal, which is in a 16 base number system, each of these digits here can be 0 to F, which corresponds to a color in the palette here. And if we were to put these numbers into VRAM on the Game Boy Advance, then we would be able to display this character here if we also had these color values in VRAM as well. So I'll now quickly go over some bits and pieces. So some of this is from my previous video on tech specs. I'm not going to go over everything from that video. I suggest you watch that one first if you've not already seen it, as I will be quickly going over some of this here. As I stated in the last video here, all of my code is built on top of DevKit Pro, which then uses the Tonk library, and all my code is built on top of that to kind of create like a simpler layer to work with and to allow me to seamlessly switch from one console to the other with a kind of common language, if you like, or at least a load of common functions. So jumping back in here, so what we want is there's 6 different graphics modes. Obviously we want a graphics mode which supports tiled backgrounds. For the purpose of this video here, I will be using mode 1, as it has 4 background layers which are for tiled backgrounds. So we will use that one as it gives us 4 layers. So you can think of we can have one text layer as the sort of like heads-up display, giving us our information like score, lives, all that sort of stuff. And then the other 3 layers below that could be various scrolling layers or whatever you want, really. So very, very useful. Background mode 1 is the best one for tiled backgrounds, really. And then our tiled maps, we can select any of these sizes here, 32 by 32 up to 64 by 64. So one tile map, I'll give you a better visualization of one here. So if you think of this as a small portion of a tile map here, it's kind of like a grid. So each number represents a tile in that background. So if you think of the this red block here, that's tile number 1. Then whenever we have 1 set in our tile map, then the Game Boy Advance knows that we want to draw this tile here in place. So another quick thing as well is each of these numbers in the tile map is actually a 16-bit unsigned number, and that number is basically built of these bit flags here. So we have 4 set aside for our palette ID here at the top. We have a flag for flipping the tile vertically, another bit flag for flipping it horizontally, and then we have these bits here which represent the tile ID. So we can have a tile ID between 0 and 511, as we can only display a maximum of 512 tiles in one character block, or tile block if you like. When we set up a background, we have to state where in VRAM the tile graphics reside, and also where the tile map resides. As per the previous video here, if we think of, so VRAM is 96 kilobytes, and then in tiled mode, which is what we're going to be, there are 4 slots we can use for a character block, which is a tile set, and each character block is 16 kilobytes in size, and each 16 color tile takes 32 bytes, which means in each of these 4 areas we could have our own character set. But bear in mind, the tile maps, which are 2K in size, also have to be within this region here. So if we were using character block 0 here, then we might want to use tile map 8 or 7. Again, you can overlap tile maps with character blocks if you're not using all of the tiles in that area of VRAM. And you could potentially set each background in mode 1 to have its own character block. But for most of the programs I use, most of the programs I've written so far, I might use 2 character blocks maybe. And then most of the time you'll want to share some of the graphics between some of the layers anyway, so it's not really a problem unless you're wanting to do some real out there stuff. So I'll get back to some of this a minute here. So before we begin, we need to turn on which background layers we want to use. We then need to state the size of a tile map per each layer. So when we set things up, we need to set up each layer after we've set what background mode we're going to have. And then, as I've said before, the tile maps and the character blocks all reside within VRAM here. And then we also so we have one palette of 256 colors in background palette RAM, and as we are in 16 color tile mode, we have 16 palettes of 16 colors at our disposal. So when we put an entry into our tile map, the first 10 bits here, if you like, is our tile ID, and then we have a horizontal, a vertical bit we could flip, and then to use a palette we also have to set a bit flag here in the last 4 to say which palette we are associating our tile with. This will all kind of look a bit easier when I get into the code in a minute. So first off, go back to the tile here. So if I come across here, so if you've not already installed LibreSprite, I thoroughly recommend it. It's a free graphics tool for Windows, Linux, Mac. So when I create my graphics here, what I do is I always keep the top row here free for the color palette, and then I draw the main character below that using the colors here. Now I'll show you a program I use here to convert these images. So all of my graphics programs here, they all use a library called SDL. I don't know if you're familiar with it. So if you want to use this program here, so this is my program here. This is for the Game Boy Advance and the Nintendo DS. So this will allow 16 color tiles, 256 color tiles, or 256 color bitmaps, 16-bit bitmaps, and I also have 2 compression formats here for compressing the images. So for the purpose of showing you how I do things here, where is it? Okay, I don't appear to have saved it yet. Okay. Bear with me a minute, I just put this one in here. So I always save it as a PNG file. And then one thing to note with the colours here is when converting from PC colours or other desktop 24 or 32-bit colours, as the DS and the Game Boy Advance are using 16-bit colours, you can think of the steps here to convert between them being in blocks of 8. So color 0 is obviously fine, but then the first color range would be, wait there, it's hard to kind of explain this, so always go up in steps of 8. This is the easiest way to convert between them here. That way the colours will align to what you can expect to see on the Game Boy Advance and the DS. So now we've saved that. Go to where you've saved it, and then all you're doing is just drag and dropping it in. It will then say how many colours it's found, and then if you click on the image, it will zoom in so you can see exactly what you got here, and then holding down the middle mouse button you can move it around to have a look. This icon here means the palette is at the top left. As it's only as we're using 8x8 tiles, we can leave these as 0 here, and then click on the save, and then create a new folder, and then just call it and then it will do that. So this is not built with any API for designing graphics or anything like that. This is just my own code which I created. This is an immediate mode user interface here, just using SDL, so it is platform independent, because there's no library stitched to Windows or Linux or any of the others. So it means I don't have to have any more libraries than are necessary here. Then you can jump in here, open up that file there, the text editor, and then if we come back in here, you should see exactly the same here. And then we can just copy this and paste it into an array. And it's as simple as that. So what I'll do now is I'll quickly show the demo. So here we go. Here we've got our character here. This is Barrio, and here's some bats. So as this is all tiles, looks like I'm missing the top tile there for him. Anyway, I've got like scrolling here as well, so it's blocky because this is moving a tile at a time. So each of these are on different layers here. So we've got the text here on background layer 0. Barrio and the bats are on background layer 1. As you'll see, if he moves over a bat, the bat is drawn after him. The rings are on their own layer, and then the rings on the same layer as the boulders. As Barrio is on a layer above them, he can appear to go over them without corrupting them. And then on the layer below that is the cave walls. So this is just a quick program to show you how you can create a whole setup here. So the tile map scrolling just loops around and around, and this obviously could be turned into a platformer, which I may do with 16 color sprites when I get to that video. Now if we have a quick look in here, so you'll see here this is background layer 0, that's background layer 1. As you can see, he's currently at the bottom there, so this has got no scroll on it here. That's background layer 2, and background layer 3 uses the full 32 by 32 tiles there. And then if we have a look at the tiles themselves, we're using character block 0 there at the very bottom of VRAM. And you can see that we are using tile streaming to animate the rings and the bats. which means we're just copying graphics data over the area in VRAM where these tiles are actually allocated, which is a simple way of animating all instances of these tiles in one go. So I will I'll just save that and close that. Don't need to do any more there. Like I said, I'll come back and do another video on the specifics of using that graphics creator at a later date, along with providing an exe file for 64-bit Windows and the source code for Linux and Mac should you wish to use this tool. So we'll jump in the code here. So as I said before, we need to say which mode we want. So this code here, if you find the declaration of that, you'll see these are from the Tonk library here. So some of the things I have wrapper code around and some things I don't. So these here, this is a abbreviation for display controller here, and then we're selecting mode 0, which in effect is the first mode, which is the 4 layered tiles there. And then we have bit flags here, ORing them together. This turns on all 4 of the backgrounds here, background 0, 1, 2 and 3. The flag at the end here is whether we want to enable sprites. As this isn't a sprite video, I've set this to false. And then if you look at the provided functions I have for the S2D block of code here, so I have here these, as there are 32 tilemap areas, this enum here provides us a simple way to just refer to which tilemap we want to use. And then I have another one here for the tile sizes. Don't worry about this one here for now. In fact, I'm not sure where I'm actually using this, to be honest. So these ones here are for defining the size of our tile maps. So when you change the size of them, obviously you are growing the amount of memory they're going to use. So if you have a 64 by 64 tile map, then it's actually using 4 of these. So to first we have to set the mode for our GBA display. Then we have to set up each layer. So what we have here is we have to set up the layer ID. So the layer ID, I have these set up here. So this simply passes these numbers in here. And then we say which tile graphic block we're going to use. We then say whether we are using 16 color tiles or not. So if you go to here and have a look at these here, we have the background layer ID, tile block ID, a boolean for if it's in 16 color mode. We then have the tilemap ID and then the tilemap size, and then the code in S2D then sets that out. So we set up all of the background layers in this demo. As you can see here, we're using tilemap 8, 9, 10 and 11. And then the other thing to note here is we set up 16 color palettes here, and then we set up 16 color tiles. So the previous step I showed you of converting graphics, you would create another source file with a U16 array for the colors of your tile, and then you would then create an array, a const array of U32 data type for the tiles, and then there'd be 8 of these U32s per tile. And then I always have a graphics define header file to keep things nice and simple here. So as we are using, just if I bring this across here and take this back, so this is loading all of our tile graphics in our init graphics function here. So you'll see the set tile data command here. All of these uses S2D BG0. The reason for that is, as I said in the video, each background layer can have its own character block or character set. When we set up the backgrounds, we pass in which graphics block we're going to be using. My functions in the S2D record all of that for each background layer, so you can forget about it once you've created the background. That way we can just concentrate on when we set tile data, we first say which background the information for the character block should be used from. So to get like a deeper understanding of this, you'll probably have to look through the Tonk library info on the Game Boy Advance to get more of a deeper dive on what's going on. These just enable us to kind of create an abstraction layer above all of this to make things nice and easy to work with. So at some point you will need to sort of dive into all of that sort of stuff to get like a very thorough understanding of it, but for just messing around, you can just, as long as you kind of know how these work, you can probably get quite far. So when we set the data for our tiles, you pass in which background ID to get the memory region to load the data into, then the tile start ID, which would be between 0 and 511, how many tiles you want are in your area to copy, and then a pointer to the array. Hence why I do this here. So I have, this is an abbreviation for graphics tile start and then graphics tile count. So I always have GFX TS, GFX TC, and then the name for all of that. and then you will need a corresponding palette color start and palette color count for when you want to load in the palette data to go with that tile. And then one thing to note here as well is there's this command here. Okay, I remember what this is for now. This is for font sets. So I've got like some code to handle different size font sets in there. So that's font set 0. This would be font set 0. So you pass in the ASCII start of the character, how many characters are in your character set, and then you say what the first tile ID is, and then the size. And then getting back in here, then you'll see. So this program here probably isn't a great example here because lots of this kind of overlaps with the font set. Normally what I would do is the reason why you have tile start and tile count is if you had another thing here, say then you could just have so what this would do then is this would use whatever value tile start was, add tile count to that value, and then this would be where our smiley tile started. The reason why you don't want to use fixed numbers here, like what I've done here normally, is just in case you want to move this somewhere. So if you change these numbers, then obviously this won't affect the smiley tile. It will always be after the tile count here. The reason why these are overlapping with that is if I show you the actual graphics to that, I'll explain it here. So if I show you the font set here, so you'll see we have this spare area here of tiles. Obviously you don't want to fill in tile 0 because that is what's always displayed on the screen. So you want to leave that blank unless you want to have like a tile pattern fill the screen constantly. So we've got a font set here, but we've got all these unused tile areas here. So what I've done is with some of the other graphics for the other blocks, I literally copy them into the same area of VRAM so that they're kind of like just using the numbers as like a peg, if you like. As you can see, the platform block here uses 4 tiles and the cave background uses 4 tiles. So there's no point putting them after the font set if we can reuse some of the tiles within that region. So as you see, they're all in that area. So one thing to note as well is some of the tiles we're using tile streaming to animate them, which is just copying over another area of the tile graphics into VRAM, kind of drawing on top of what was previously there to give us easy animation. So you'll see that all of the tiles there, they all have their own array, And then you notice here that the ring graphics uses the same palette as the font, so there's no need to create another palette for that. And then down here I have some defines for the palette IDs to use for our tiles, and then these defines here are which tile number to use to draw all of our characters. So this just sets up constants for the graphics to use later on in creating our scene. So this initializes our graphics, this sets up our display. We initialize the rand function here, and then this is just this is a state machine, which is I use for all my games to keep things nice and easy. A state machine can only have one state, so if I jump in here, this is our main state enumeration here. Main state is these are global values, and then these are the external functions which map to these state cores. And then don't worry about the game tick thing here. This is purely to kind of slow things down to some degree. Oh yeah, there's also the I've left in the sound manager code here. Let's have a look. I can't remember whether I actually put anything in for sound or not. Obviously this demo isn't about sound at all, so okay, there is. If you press A, there's play some sounds in here. So I've also added in a palette fade, some palette fade code. This is purely for one of my other games I'm working on. I kind of put it in here to test it first. So all of the sort of program here is pretty much the main function here. Just sets everything up, and then pretty much everything is just working inside the title screen code here. There's nothing really sort of magic going on in here. Again, you'll need to sort of check out the code to get a real sort of understanding of what's going on here. Some things relevant to the S2D is all I want to sort of cover really. So when drawing tiles with the Scene 2D functions here, first off we need to say which layer we want to draw a tile to. So your first S2D active layer. So what this would be is either backgrounds 0 to 3 here. I've created an enumeration just for this specific demo here, where the heads-up display is background 0. So by default, background 0 is drawn on top of all of the other backgrounds. You can change that, but I won't in this demo here. So by default 0 is on top, then 1 is below that, with 3 being drawn at the bottom there. And then these are just some structs here to hold hold of stuff. So the print functions, as long as you've got a font loaded in and you've defined that font first, which we did here. So this sets up our font set here, as I showed you previously. I'll quickly open that back up again to quickly give you a rundown of how you should be setting fonts up. So in accordance with the ASCII format for fonts, this is how this is kind of built here. So this is tile 32 here, which is the space glyph, and then so whenever you press the space key, it's actually tile 32, but we also need tile 0 to be blank as well, so always have tile 0 and tile 32 blank. And then in all character sets, the this row and the one below that is used on the sort of desktop and some other consoles, but obviously it has no meaning at all on the Game Boy Advance or the DS. So these are free graphics that we can kind of use here. So there's 128 tiles in total here. Obviously you can make this as big as you like, and then always remember to have your palette in the top left here if you are going to be using my graphics program to convert those to usable data. So jumping back to this, so in our print command here, set in the font ID and then the start X and start Y tile location. If you use just the standard print, then you can just pass in a message as normal. If you want to use extended print, then we have the variable arguments bit at the end here, so you can pass across some numbers, like as you can see here, the print center EX, this one here has the variable arguments bit after it as well. Obviously if you're not sure anything works, just play around and have a look. The beauty of all of this being provided as is, as in not compressed into a library, is you can obviously see the source code underneath it all. So there's a few functions in here. So this will draw a normal size tile. This will draw a double height tile. So it will just draw one with another tile below it. This will draw a 16 by 16 tile. This will draw two tiles next to each other horizontally. And then our barrier character is actually 16 by 32. So if I open him up here and then zoom in, here's our palette for him, and then you'll see if I set this up in grid settings here, so always put one there as like a spacing thing here, so then you'll see that he's split into 16 by 16 pixel blocks. So that's used to plot him there. Where are we? Okay, so we are using the no, we're not using game code actually, we are just all in the title screen here. So there's actually not a lot in here. Obviously looking at it, it looks like there's a lot going on because of the all the animations, but that's just a where are we? Oh yeah, there's some code in here as well in the level manager stuff. So I'll stick with this a minute. So you can use fill strip X to fill a horizontal strip with a given tile, and then fill strip Y obviously does vertically. You can also do fill a rectangle here. Now if you had like a huge image made of tiles, like in the tech specs demo, I converted some images into 16 color tiles, and then you can use this to draw a big character made of tiles here. So this TX and TY is your starting position, TW is tile width and tile height, so that's how many tiles go across horizontally and vertically. So you could use that to draw the barrier character here, so the width would be 2 and the height would be 4 to draw him. And then that just clears the a background layer here, so you would pass in which background layer ID to clear. So if we okay, it's not going to be in there. If we go into here, this is just some level manager stuff here. Here we go. So in the level manager initialize function here, this clears all of the free background layers. One of the reason why it doesn't clear background layer 2 is because it draws on that next. So back to these functions here. Clear all obviously clears them all. And then you can use this command here to scroll one of the background layers as is happening in here. So I'll now jump between some of the code here. So there's a virtual camera in use. This here, center camera here. So this centers the virtual camera. Okay, I'll explain the virtual camera here. So if you are, when you're working with any sort of scrolling game, you create like a virtual camera. So you can think of like a virtual camera as being like a rectangle area which is centered over, say, the player. So get to some of the bits in here a minute. We have a vec2 structure here, which is just to hold a pair of numbers. So we have in here this variable here called camera view. This is the top left coordinates of the virtual camera here. So all we're doing here is the camera in this case here, we don't need it to follow the player X position here. Lots of the code in here is actually from another game I'm actually coding at the moment called Boulder Crash. So for this demo here, this is just following the player's Y position here. So the camera actually is 72 pixels above the player's Y position, which is the vertical position of the player. And then you can use this to scroll the background layers, which is what's happening here. As you can see, it's scrolling 1, 2, and 3. The reason why it's not scrolling 0 is because obviously that's our heads-up display or our sort of like text area, which we don't want to scroll. as the tile map's set to 32 by 32, if you uncomment some of this and have a mess around, you'll see that the tile map wraps around horizontally and vertically when you go past 256 at each coordinate. And then so some of this stuff here is kind of outside of this tutorial here. These are just bits and pieces to hold the start positions of our characters here. So there is actually, this is the level setup to draw that display there. Again, this is outside of the what I'm aiming to sort of cover in this tutorial here. Have a look through all of this anyway. Some of this might be of some use to you. See if you can get a grip on what's actually happening here. This is common code which I use here in my initialize levels thing here, where we point to our level data and then we just compare it to our level tiles. So for this demo here, the level consists of, I'll bring across the level. So when I design levels, I usually design them in here as well. So the palette in this case for the level actually represents tiles, not pixels. The one is the walls of the level, which are the dark ones here. Green is the player start, which is there. Red are the enemies, which are the bats in this case, and yellow are the rings. I then use the DS to tile to convert it into a 256 colour bitmap, which then outputs 1 byte per the sort of like tile, if you like. So as you can see, these mirror that image, and then in here we have the walls behind, which are 0, 1 which is the boulder there, 2 is the player, which is just there, and then using that sort of makeup there, we can then iterate over that array and then either draw those tiles directly or record the positions of where they are in the sort of game world, if you like, and then use those to create those sort of players. So the animation, which is one thing I wanted to cover, the sort of like tile streaming thing there. We have a timer set up. When we initialize the level, there is where are we? There we go. So our tick timer is set to 15, and then in this demo here, as it's running, you will see level manager update chord, which comes in here, and then it just counts down the timer, and then these numbers are the current frame of the bat or the ring, and then update bat graphics and update ring graphics are called, and then all they do is copy data from the graphics array into the tile start location of the bat in the update bat graphics, or the ring in the update ring graphics. So it also means that we're not loading in all of the tile data into VRAM at any one time. We're only copying in 4 tiles at a time. So if you look at the define for that, you'll see it's 4 for the bat, and it should be 4 for the ring as well. So don't think there's too much more I really want to cover here. Hopefully this will be useful to you. Have a play around. So I'll quickly go over the input class here, or function, sorry. There's not a lot in here. This is just wrapping over some of the sort of like more tonk input stuff here. It's just there to kind of provide the same sort of functions as in my other sort of libraries here, where we have input is key down, and then these defines here are not mine either, so you can find all of them in here. So these all correspond to the available buttons you can press on the Game Boy Advance. And then there's some other useful ones here where he's, for example here, key accept, he's put 9 there, whereas as you can see it's the same bit flags as key A and key start. Just some nice things he's put there for us. And then as you can see here, I've put some clipping functions in here to limit our locations that Barrio can travel to. Describing how the sort of palette fade stuff works isn't really part of the this sort of tutorial here, nor is this sound stuff, but I'll leave it in anyway for you to sort of have a look at. I think I've put some descriptions for how to use the palette thing in here. So if you're going to use any of the palette fade to black is straightforward. You don't have to do anything much for that. Whereas if you want to fade into a palette or a number of colours, then you first have to load those into a temporary array in here first, which is what I've done in here. So if you run this, check it out, see how that sort of goes. See that there's as none of these are using sprites, there's no need to have a sprite bit in there. And then this number here is just a delay value. Not too much going on in here. This is just to give you a good feel for, or rather a starting program to play around with for getting used to working with 16 colour tiles on the Game Boy Advance. So that's it for this tutorial. If you've got any questions or anything, then let me know. I will create a video shortly, as in within the next couple of days, once I've built the Windows version of my graphics tool. And then I will show you in detail how you can use it to create all of the graphics needs for the DS and the Game Boy Advance. Alright, that's it for this video. Thanks for watching, and I will catch you next time.